What is a defrost time clock and why do we need one? Okay, this is going to be a bit of a different video. I kind of decided to do this on a whim. This is basically one of my earlier presentations that I've put together for a lecture. It's on defrost time clocks. So if you've been in or around refrigeration for a little while, then you'll probably have an idea what that is. If you don't, it's going to be great for you. If you know nothing about refrigeration, you'll probably find this entertaining as well. If you've been doing refrigeration for 30 years, you're going to get to see how something that's pretty common in our trade is explained using the method and technique that I use. And so without further ado, I'm going to get right into it. It's going to be about a 10-minute presentation, so or lesson, if you will. And so I'm basically going to go through this exactly like I would if I was giving this lesson in front of a class or if I was doing it online. There's really no difference. So without further ado, this is the operation and functionality of a defrost time clock. Now, the obvious question that you're probably wondering if you don't know what one of these is of course, what is a defrost clock and why do we need one? Before we answer that question though, we're actually going to rewind it back a step further, just to make sure all of us are on the same page and we all have the same kind of fundamental knowledge and understanding of what we're talking about. We're going to ask a more basic question. We're going to ask, what is water? And most of us would agree that this is water, and this is water, humidity, fog, this is water. And most of us would also say that, well, this is also water. Now, in refrigeration, we turn vapor into liquid, and I'm referring to water specifically. In our process of refrigeration, we take water in vapor form and we turn it into liquid as a consequence of our process. Now, this is referred to as condensation. Most of us know when you see condensation on a window like this or on a mirror when you're having a hot shower in the bathroom, what's actually happening is warm, moist air is coming into contact with a colder surface, and then that moist air, that water that's in vapor form, the humidity, it's condensing to liquid form, and that's condensation. So in refrigeration, this is exactly what's occurring. We have warm, moist air, water in vapor form, coming in contact with our cold coil surface area. That water then converts from vapor into liquid, and then this gray plastic drain pan you see drawn under our coil, that's going to collect the water and we have to kind of deal with it. But sometimes our process being refrigeration, turns water into frost or even ice. And then we get a situation like this. When this occurs, then we need to deal with it. And so step number one, if our process is cooling, refrigeration, and refrigeration is what causes our problem, then we need to temporarily stop our process or stop creating more of the problem. We need to turn off the refrigeration. Now, there's two types of refrigeration where the defrosting of a frozen coil will be required. We have systems that run above freezing, and we have systems that run below freezing. So step number two. Now, step number one, we need to stop our process. We're going to stop creating the problem. So we stop refrigeration. Once we've stopped the thing that's making our frost or ice, now we need to get rid of the frost or ice. We need to initiate a defrost. And we can do this one of two ways. We can do this manually, simply by turning off our refrigeration, or we can do this automatically. And we enter into our defrost time clock. First time we're seeing this image. Now, we're not going to talk about it quite yet because we need to go through a couple of different types of defrost. And the first type we're going to talk about is called air or off-cycle defrost. Now, one of the things I love most about refrigeration and thermodynamics in general is so many components and terms that we deal with are so self-explanatory. You don't need to be a refrigeration mechanic or an engineer to understand that air or off-cycle defrost probably has something to do with air, and it probably has something to do with off-cycle. So what do we mean by off-cycle? Well, inside of a system where we don't cool the temperature of the space below freezing, that means that once we get close to freezing, so I'll give you an example, a walk-in cooler at a big commercial restaurant where they store all their product that they want to keep cool, but they don't want to freeze. This would be like a giant refrigerator. We're going to keep that space around 2 degrees Celsius, or approximately 34 Fahrenheit, 35 Fahrenheit for my American friends. Really, this is the range of optimal temperature for a cooler, but you have to think for a second. If our system, this big gray box with the fans, has been cooling that space down to that temperature, there's a very real possibility that the surface of the coil has dropped below zero, and the humidity in that space has now started to convert into frost, and our coil becomes covered in frost. And so, as we've discussed, we need to initiate a defrost. Now, when we get to temperature, when the box or the space that we're cooling is where we want it to be, the refrigeration shuts off because we don't want to freeze the product. And those fans you see, they continue to run. Now, the temperature of air in the space, as we've mentioned, it doesn't go below freezing, so it's still above freezing. And so the air that is above freezing will then come into contact with the frost. The frost will turn into water, and then the water is carried away by this drain pipe. Okay? The only thing, now watch this, the only thing initiated for defrost is the refrigeration off cycle. This is in an air or off-cycle defrost scenario. All we do is interrupt the refrigeration cycle and allow the warmer air warmer than the temperature of the frost, to melt the frost into ice. Okay, the only thing initiated is the turning off of the refrigeration. Now, the next type of defrost that most of you refrigeration mechanics or people who've worked around this stuff will know is electric defrost. So we've got our evaporator coil. It's our refrigeration coil in our unit that would have been inside of that box hanging from the ceiling in the previous picture. And embedded in the coil, we have these black metallic rods that are our electric heater elements. Okay, and so basically those heaters are energized after the refrigeration is turned off, and then the heaters melt the frost. So this obviously applies to systems where we have our interior temperature or our box temperature below zero, because the refrigeration turns off. If the temperature of the air is below freezing, it's not going to melt the frost or the ice very well. We need additional heating. We need the electric elements to turn on and melt the frost. There's a few other types of defrost. We've got hot gas defrost, and we've got water defrost, but hot gas will take way too much time to explain for this presentation, and water is an obscure and terrible system that doesn't work. I'm hoping someone puts into the comments how much they love water defrost, because I would love to talk to you about it. I've never seen one that works without problems, but that's all I'm going to say about it for now, because we've got to move on. So step number 1, we turn off refrigeration. Step number 2, we initiate a defrost. Now, step number 3, we need to control the length of the defrost cycle, and therefore we need to terminate or end it at some point and then resume the refrigeration cycle, because obviously if we stay in defrost forever, our product's going to get warm. We're not going to maintain refrigeration and maintain temperature of what we're trying to cool down. So we bring in our defrost time clock. Now here it is again, and if you've never seen it before, it probably looks a little more like a time machine than it does a clock. And so I'm just going to identify some key components to it right now. These little pins you see nicely organized in our carrier here. These are our pins we have to identify when we want a defrost to occur. And these little holes around the circumference of the dial are our available defrost times. Now, we've got an inner dial as well. And so very interesting here, we've got holes or available defrost periods every 2 hours. And we have defrost time with intervals in minutes from 0 to 120 minutes. So that gives us the ability to basically initiate a defrost at every 2 hours. And we can run it for up to 2 hours. So if we had a pin in every hole and the timer is set to 120, the system would essentially be in defrost all the time. So that's a lot of information if you're not familiar with one of these. So I'm just going to go through it again really quickly. We have these holes every 2 hours where we can put a pin in. And if you look at the cog in the upper left of the picture where it says time, that's a little cog or a little lever that's going to be tripped by our pin when it hits it as the clock rotates clockwise direction, and then we're going to initiate a defrost for the period of time that we set the inner dial to. So currently, you will see that we have a single defrost period set for 8 a.m. Is that, yeah, 8 a.m. at the bottom, number 8, there's that pin screwed in. So every day at 8 a.m., we're going to initiate a defrost. That's 40 minutes because our little copper tab is on number 40. And so there's a couple other things we need to talk about real quick. There's our terminals. So power is essentially going to go between the bar between 1 and 2 and N. We're not going to get into any more of that right now because this is just the basic introductory lesson. And so that's our power. That's going to drive the clock. And we have terminal 4, which is typically going to be used for refrigeration. So when we're running the way the clock is right now, we have a signal coming from number 4 telling refrigeration to turn on. When 8 a.m. arrives and we initiate a defrost, that signal is going to be broken and we're going to energize terminal number 3, which is going to initiate our defrost. That's our signal telling defrost to come on. Now, X is for termination of our defrost, and that's very cool how that works. We can talk about defrost termination fan delay switches. I'm not going to get into that right now, though, because this is just the entry into our clock. We'll talk about that another time. This is the important part to remember. For air or off-cycle defrost, the only thing we need to worry about is number 4, because we're not initiating anything. We're just turning off refrigeration. Number 3 is our signal to initiate defrost, but we're not telling anything to be initiated. During electric defrost, or hot gas, then we would connect number 3 to something, because during defrost, we need to enable something to happen. And so to recap here, we know that our process, refrigeration, can cause water to freeze, and this can be a problem that we need to deal with. We know that we need to first stop the thing causing the problem, and that means the refrigeration needs to turn off. We know that we need to initiate or start a defrost, and we know that we will need to terminate or end the defrost cycle at some point and then resume the refrigeration cycle. And we know we have multiple ways of defrosting: our coil, hot gas, electric, air, so on and so forth. So that's our basic 10-minute or so presentation, maybe a little longer than that, on the operation and functionality of a defrost time clock. All right, so that's about all there is to it. I've got a few like that, and someone had messaged me saying, you should just do those presentations that you had done before. So I thought I'll throw them on and see what you think. And if it's a little different than what you've seen before in presentations and in school, then that's definitely been my experience as well. So let me know your thoughts. What did you like? What did you not like? If you have any more questions about time clocks or about refrigeration in general, or putting together super simple presentations for your lectures and your lessons like that, I'd be happy to converse with anybody about all that stuff. So that's all I got for today. Stay tuned for more, I guess, and have a great day. Bye for now.